All right, so today we're gonna start on the first chapter, describing data using graphs. We're gonna um, go over this diagram real quick again. We've seen this through the first online meeting. So to start, any research, when they want to conduct a study, they're always gonna have a group of individuals that they're interested in. For example, if someone want to study, all the horses in New Mexico, then all the horses in Mexico will be their interest. And that group of individuals is called population. Okay. So then the researcher must want to prove something or, prove, something about a population or make some conclusions about the population. And they also want people to believe in his research, right? So how do you make your statement, trustworthy? How do you make people believe your results? You need evidence, right? So where does evidence come from? From data, right? So then we need to basically collect data from the population. We need to measure it, right? But the problem is, if we want to measure the entire population, the population size is most of the time very, very, very large. So for example, if you want to study all the trees in New Mexico, then how many trees are there? How much time would it take you to go measure every single tree? It will take forever. So it's not really practically possible. So then how do we measure? We still need to measure data, right? So we don't measure the entire population, but instead, we're only gonna take a small portion of the individuals out from the population. And that group is called a sample. So for any research, there is a population, also there is a sample. The population is the interest. The sample is the data being collected. Okay. So then there are many individuals in the population. What individuals will be chosen into the sample, right? So which individuals is a good individual to be chosen? That will involve something called the sampling process. We're not going to talk too much about the sampling, but we're going to introduce a few different sampling process. So basically, the rule is you want to choose individuals into the sample so that the sample will be a good representative of the population, right? So how do you make that? It's not really possible, but the best way to do it, the best way to get a good sample is by random sampling. So you don't choose individuals on purpose. You choose them randomly without knowing what they are, and you choose them. That way, the sample, is unbiased. So it's a good representative of the population. And then once the sample is collected, now we can go ahead and measure the data. And that's something, we can manage. So we have a data set about the sample. Then what can we conclude from the data? So we need to describe the data. So describing sample data is called descriptive statistic. So you can describe the sample, some trend of features from the sample. We use some tools. Okay. So there are generally two different ways to describe the data. One is using graphics. That's what we're going to talk about today. And the other is also for the same feature you see from the graph, you can calculate some measure as well. So you can calculate some numbers to describe the data, right? So that's numerically we're going to talk about next class. So after you describe your data, you know exactly what's going in the sample, but that doesn't answer your research question. Your research question is, what's going on in the population, right? So then, how do we draw conclusions about a population? We need to go through another process called inferences. So an inference is a procedure to draw conclusions about the population based on the information from the sample. Then there is a link in between the descriptive statistic and the inferential statistic. That's the theory part of the class. So we also need to learn about probabilities and distributions. So that's, the complete process of the statistics. And we're going to have 3 clusters, basically. One is descriptive statistic. The other is inferences, and then theories, probability and distributions. Okay. So that's it. And make sure, anytime when we go through a new concept, try to think about this image and think about what that chapter is, is belong to in this process. And that will help you to link all the, chapters we learn together. And also in our class, we have some reserved symbols. It will be very, very helpful that you can memorize what each of the symbols represent. They will represent some kind of measures of the data. And it's not many, only, 1 page full. I think it's 10, 11, 12 symbols. So please go over the symbols, often so that, you understand what each symbol represents. We're going to go through this very quick. For a small n, that represents the sample size. So basically, when you have a sample selected, how large is your sample? How many individuals are there in a sample? That's sample size, okay? And then big N is population size. That will be, number of individuals in the population, right? Okay. And next term is sigma. So this is pronounced as sigma, and that's population standard deviation. And then S, it's sample standard deviation. Okay, so they're both standard deviation, but they're referring to different groups. Sample standard deviation, population standard deviation. Like here, size of the sample, size of the population, right? And next one is mu. Mu is population mean. So pronounced as mu, population mean. Mean is just another term of as average. So anytime when you see mean in statistic, that means average. So average of the population. And then X bar is sample mean. So we call this X bar, and that represents average of the sample. Okay. And then Z is a standard normal variable. We're gonna learn about normal distribution in a while, after first exam, I believe. And the R is correlation between the 2 numerical variables. So sometimes we know some variables related. So for example, the car's weight and the car's MPG values. So there is a relationship between car's weight and the car's fuel efficiency, MPG. And what's the relationship? Can we use a number to describe it? And that's what a correlation is, okay? And then B1 and B0, that's regression slope and the regression intercept. So basically, it's what you learn in the math class. For any straight line, we can use a function equation to describe it. Y equal to mx plus b, right? M is the slope and b is y-intercept. So this is the same idea. B1 is what is a slope, and B0 is y-intercept. Okay. And then p-value and alpha. P-value is a kind of probability, and that's very useful in inferences in hypothesis test. And we're gonna learn about that in the inference part of the statistic. So the inferences. And then the last one is alpha. P-value and alpha, they always come together as well. So we use p-value to make a statistical decision, but how do we make it? We compare it with alpha. So we're gonna learn that later on. So please go over the symbols, make sure you recognize each of the symbols and understand what they mean. Learning objective. So we need to be able to identify different type of variables from data. When you describe data, you're basically just describing variables. Then what kind of variables are there? So we need to be able to identify what kind of variables are they, and then we can use appropriate graph to describe it. So that's the idea. So in general, we have 4 different types of variables: nominal, ordinal, discrete, and continuous. We're going to talk about how to differentiate between them. And then able to produce and interpret common graphs. So we have some common graphs we use to describe data. bar chart, pie chart, stem plot, histogram, they're very widely used. So we're going to learn about how to make them and what kind of information we can get from, from them. All right. So univalues and variables. Univalues are objects being described by a set of data, maybe people, animals, or things. So basically, when you have a data set, what objects being described by that data set, that will be called a univalue. So basically, that's a research interest. If you want to study horses, you're going to collect data about the horse will be univalue. If you're interested in buildings, you're going to collect data about building, right? Then building will be a univalue, right? So whatever the research interest, that will be univalue. And a variable will be any characteristic of individuals. So for example, if you want to study horses, then what kind of feature are you interested in from a horse? So you can have horse height, horse weight, right? And horse age, horse gender, right? So any of those characteristics of that individual is called a variable. So for many, many different univalues, you can think of, different kind of variables related to it. For example, if you want to study cars, then car has different characteristics. Models, make, year, country, where it's made in, how many cylinders are there, how many seats is there, the price, the MPG, everything, right? For hotel, you can think of when you book hotel, what kind of information do you look at before you book hotel? The hotel name, city, state, the distance from the airport, the distance from the attractions you want to visit, and the price, and amenities if they have swimming pool or internet. So all these are variables about individual hotel, right? So now we talked about different kind of variables for individual. For example, the model of cars, the makes of cars, the years of the car, how many cylinders there, the price, and everything, right? Are all the variables the same type of variable? Are some of the variables different? So to think about it, for model of the cars, so you have Toyota, you have Honda, you have Buick, right? So what does those variable do? Right? So it categorizes, right? So it categorizes the individuals into different groups. All the Honda, cars will be one group, or the Toyota car will be the other group, right? So categorize. For this kind of variable, we call it a categorical variable. So it categorizes the individuals, right? And then for another variable, for example, a year of the cars or the price of the cars. So that doesn't categorize anymore. It's a measure of something, right? So it's a numerical measure of some features of the individuals. And that kind of variable, we call it a numerical variable. So in general, we have two different types of variables. One is categorical, which categorizes the individuals, and the other is numerical variable that provides a numerical measure of some individuals, right? So then, that's in general, numerical and categorical, the big categories. How do we determine if a variable is numerical or categorical? It's pretty easy. So to be a numerical variable, it has to have a numerical format. And also it makes sense to calculate. Okay, so it need to be a numerical format. For example, 1, 2, 3, 4, 5, right? And also it also need to make sense to calculate. There are some variables that has numerical format, but you can never expect to calculate on them. For example, when you come to MSU, everyone will get a student ID, and student ID is 800 number, right? So it's a numerical format, but can you calculate anything out of it to make sense? When you subtract your student ID with another student's student ID, when you make addition, subtraction, taking average, would it make sense at all for the results? It doesn't, right? So those kind of variable is not numeric, even though it has a numerical format. There are a lot of other examples you can think of, like bank account number, zip code, telephone number, social security number. All these variables are not numerical. And when they're not numerical, they are categorical automatic, right? You only have two groups. If it is not A, it's B, right? So then for numerical variable, now we're going to focus on numerical variable. If some variable is numerical, we can put them into either a discrete variable or a continuous variable. Okay. So what's the difference between discrete and continuous? Okay, so let's think about continuous variable means the variable can take all the possible real numbers in a reasonable range. So for example, student body weight. Let's say the reasonable range is between 100 and 200 pounds. Is the variable able to take all the possible real numbers between 100 and 200 for student body weight? And everyone should know what a real number is, right? All the numbers that you know of, right? So the student body weight could be 150, 150.1, 150.11, 150.111, and so on, right? So that variable could take all the possible real numbers in a range. So that we call that variable a continuous numerical variable, right? And on the other hand, if the variable is not able to take all the possible real numbers in the range, then we call that discrete numerical variable. So what kind of variable is discrete? For example, the number of seats in a car. This car has 4 seats, that car has 6 seats, right? Do you have a car that has 4.1 seats, 4.2, 4.22, and so on? Now, so then the number of seats in the car is called a discrete numerical variable, right? Okay, so if a variable is numerical, it will be either discrete and continuous, and then we know how to, differentiate them. Now let's look at a categorical variable. If a categorical variable can also have 2 subsets, nominal and ordinal. Okay, and the difference is if there is or there is not a meaningful order among all the categories. So basically, the categorical variable give you different categories, right? Is there a meaningful order among the categories? If there is, we call that an ordinal categorical variable. And if there isn't, we call it nominal categorical variable. So a good example is, everyone in the class, by the end of the semester, you're going to get a grade. And in this class, we're going to give a letter grade, just A, B, C, D, and F, right? Is there a meaningful order? We know A grade is better than B grade is better than C grade is better than D, and D is better than F, right? So that's an example of an ordinal categorical variable. And like, the student has a major, then what kind of variable is student major? It's categorical for sure, then is it nominal, ordinal? So when you think about someone majored in chemistry, in physics, in biology, is there a meaningful order in there? So when we say meaningful order, we don't include alphabetic order. Everything has alphabetic order. That's not counted, right? So of course, student major will be a nominal, right? So now for any variables, we should be able to tell what kind of variable is it. Categorical or numerical. If it is categorical, is it nominal, ordinal? If it's numerical, is it discrete or continuous? This is easy stuff, right? Okay. So now let's look at a practice. So for example, we have a small data set here, and we have a bunch of variables collected. And then we're gonna look at, so this is a data set. When you look at this, what types, what are the individuals from the data set? So basically, what does the data set describe, right? What objects or, things does the data set describe? It looks like it's describing students, right? You have major, you have exam grade, and so on. So this is the individuals or students. Then every variable will be a characteristic of, the students, right? So in a data set, is the common structure is like this. Every row is an individual. So you have different students on each row. And every column will be a variable, right? So you have the matrix form, rows and columns. So we have a bunch of variables. We learned there are 4 different types of variables: nominal, ordinal, discrete, and continuous, right? So let's go through the list and see what kind of variable are each of the variables. So for example, student ID, even though it has a numerical format, is a numerical variable? No, it's a categorical variable, right? So then what kind of categorical? Nominal or ordinal? Is there a meaningful order in the different categories? There isn't. So this is a nominal categorical variable, right? And student name, same reason, nominal categorical. And student gender, even though it shows as number 1 and 2 in a format, it does look like have a numerical format, but doesn't make sense to calculate. So can you calculate anything between the student gender 1 and 2 out and it makes sense? Adding, subtracting, taking average, it doesn't make any sense, right? So gender is a categorical variable, right? And then what type of categorical? Nominal or ordinal? Of course, it's nominal. There's no order, right? And the student major, same deal, categorical, nominal. Exam score, so this exam score reasonable range is between 0 and 100%, right? So then, can the exam score be any number between 0 and 100? Can it be 59.1, 59.2, 59.21, 59.65, and so on, right? So the exam score can take any number in a range. We call that a numerical continuous, right? It's a continuous variable. It can take all the possible numbers in a range. And the exam grade. Categorical for sure. It doesn't even have a numerical format, right? Nominal, ordinal is ordinal. We talked about it, right? Student age. It's numerical for sure. It makes sense to calculate, right? It's numerical format. But is it discrete or continuous? Right? So with the age, when you report your age, the reasonable range, for example, to say it's, between, for college students, between 17 and 80. Because someone's age be 21.123, 24.06. So it cannot, right? So in convention, we only report our age by the whole numbers. I'm 21, you're 22, right? So in this case, age is a numerical variable, but not continuous. It's discrete. And then the last 3 variables, the same type. They're just indicating whether the student possesses that electronic device. So that will be, for sure, categorical variable. It doesn't even have a numerical format. Then which categorical? Nominal or ordinal? So cannot call this a nominal, right? It's nominal variable. Right, so this is the first breakpoint. This is the first animal for attendance points. So, on a canvas, he will ask you some, just like attendance points, just to make sure that you either watch the video or, you watch the PowerPoint files, basically studied. And you're gonna see 2 animals for each chapter. And, that will be asked on Canvas for attendance points questions. Right. So now let's talk about the deal here. So the chapter is about describing data using graphs. So how do I use graphs to describe data? So then we learned different type of variables. We have categorical variable and numerical variable, right? So when you describe the data, you need to look at what variables you want to describe. You're not going to describe all the variables at the same time. So most commonly, you can describe a single variable, just look at that variable by itself, or you look at the relationship, they're only for numerical variables. And we're going to talk about that. So most of the time, we look at just one variable. So then based on this variable feature, is it a categorical variable or is it a numerical variable? Then we decide what chart to use, what graph to use. So for example, pie chart and bar chart are used to describe a categorical variable. And then stamp plot and histogram are used to describe a numerical variable. Right? So that's pretty easy to see, right? So for example, then let's describe some variables here. So we're gonna first describe categorical variables. So for example, we have gender and major, right? So then if we look at the major, it's a categorical variable, and we want to describe this. If we want to describe this data by this variable, we need to make a pie chart or a bar chart, right? Because of categorical variable. Then how do I make a pie chart or bar chart? So here is how I do it. So when you look at a student major, you have chemistry, physics, chemistry, biology, chemistry, physics, it could go on and on, right? So to make a pie chart or bar chart, first you need to make a frequency table. Okay, so basically the frequency table has major as the first column and lists the distinct values in that variable. So we have 3 distinct values: chemistry major, biology major, and physics major. And next, we need to count correspondingly how many individuals or how many students are in each of the 3 categories, right? So I have 4 chemistry, 2 physics, and 4 biology, right? So count it out. And then we can calculate the percentage based on the frequency, right? So you have total of 10 students, and 4 will be 40%, and 20% and 40%, right? And then once you have the frequency table, you can make a pie chart for major. So when you have 3 different categories, you're gonna draw a whole pie, and then divide a pie by the proportion of the percentage here, right? So 40%, 40%, 20%. This is chemistry, this is physics, and this is biology. So have a good label to make sure, you know, people can read your chart. And the same deal, you have gender, you can do the pie chart very similarly. Just now you have 2 categories, only male and females, right? And they draw proportion. You have six students as males and 4 students and females. You know, in a pie chart, you can do either a frequency pie chart or percentage pie chart. Basically, just you label them differently. If you label them by frequency or by percentage. And for the same deal, if you are able to draw a pie chart, you should be able to draw a bar chart as well. So based on the frequency table here, for a bar chart, we just need to draw 3 bars, 1 for each of the major, and then the y-axis will be either frequency or percent. So for example, if you do percentage, then the bar height will be the corresponding percent for each categories, right? So chemistry 40%, biology 20%, and physics is 40%. So that's your bar chart. And same deal for gender. You know, you have 6 and 4, right? So you can, if this is y-axis can be frequency, right? So I have 6 and 4, right? So bar chart again, you can do frequency or percentage. It give, you know, it's dependent on what your audience want to look at. Some people prefer counts, some people prefer, you know, percent, right? So this is idea of a pie chart and a bar chart. As you can see, most of the bar chart and pie chart give us exactly the same information. It gives us like a proportion, right? So what percent of students are males, what percent of students females? And they are giving us exactly the same information. So most of the time, bar chart and pie chart are interchangeable. But there are occasions that, you know, bar chart can be used, but the pie chart is not. So we're gonna talk about a small example here. So for the last 3 variables, whether a student possess an iPad, iPhone, or iPod, we have a bunch of yes, no's responses. So if we wanna see what percent of students have iPad, we're gonna count for iPad will have 60th and divided by total of 10 students is 60%. And what percent students have iPhone? That's, 3 divided by 10 is 30%. Having iPod, it's 3 divided by 10 is 30%, right? So we want to present this into a chart. Can we use a pie chart? This is a categorical variable, right? So then we have to use a pie chart or bar chart. Can we use pie or bar? Right. So this is the limitation about the pie chart. The pie chart has to be a whole pie, and a whole pie can only be exactly 100%. It cannot be more, it cannot be less. So when you add the percentage up, 60, 30, and 30, that's 120%. That's more than 120. That's more than 100%. You cannot use pie chart. Pie chart has to be exactly 100%. You cannot have a pie that's more than 100%. You cannot have a pie that's less than 100%, right? It's not a whole pie anymore if that's the case. So we can use a bar chart, either a frequency or percent bar chart to show the feature here, but we cannot use pie, right? So bar chart and pie chart are very easy to make. They're very easy to interpret. Basically, just give you different categories. We focus on more numerical variables. That's what make it a little bit more complicated, right? So then for the data set, we're going to look at a numerical variable and look like the exam score is a numerical variable, right? And it's actually continuous numerical, right? So then we want to describe this exam score. Since this is a numerical variable, we need to use either a stem plot or a histogram, right? So we're going to talk about both. Right, so we have exam score, 61, 91, 76, and so on. So now we're going to sort this exam score in an increasing order. Most of the time when you describing numerical variables by hand, you want to sort it out so that you can, you don't miscount some numbers. But nowadays, we can use softwares to make those charts very quickly. But understanding how to make them is still useful so that you have a better understanding of the graph. All right, then how do we make a stem plot of the data set? Right, so first we need to understand for each value in a variable, we need to separate each number into two parts, a stem part and a leaf part. And the separation is very, very simple. The rule is simple. So for every numbers, they need to be in the same format. Then the last digit on the right is your leaf. And everything else to the left will be your stem. Right? So for example, you have a number 21 here, right? So leaf will be 1, stem will be 2, right? And for the number 91, leaf will be 1, stem will be 9, right? So once you have that separated, drawing stem plot is very, very easy. So for example, you're going to use a paint here to show you how to make a stem plot. So we have the data values here, right? So first thing we're going to draw a line. And the line going to separate two parts. On the left will be your stem. On the right of the line will be your leaf. Right? So then we're going to look at our data set. For the stem, what's the smallest stem? And what is the largest stem? You can see smallest stem is 2, largest stem is 9, right? So then we just need to go here and type in from the smallest to the largest without any missing ones, okay? So from 2 to 9, that's our stem, right? And then on the leaf, basically now we just need to assign each of the leaf to the corresponding stem. So for example, for stem 2, what leaf do we have? We only have one leaf with a value of 1, right? So on the stem 2, we have a leaf 1. On stem 3, what do we have? We have nothing. We have 0 leaf, right? Don't put a 0 here. This is the leaf value, not number of leaves. We have 0 leaves, but the leaf is missing. We don't have any leaf on this stem, right? And so the next stem that has a leaf is 60. So 3, 4, 5 stem has no leaf. And the 60 has a stem of 1, right? So we need to put a stem 1, we need to put a leaf 1 on stem of 6. And then next, stem 7, we have 3 leaves, 3, 6, and 7. So we're gonna put 3 leaves here, 3. You can put a comma or space to separate them. 3, 6, and 7, that's on stem 7. And then stem 8, we have 3 leaves as well, 1, 6, and 8. And then lastly, stem of 9, we have 1 and 2 as a leaf, right? And once you get this, your stem plot is done, right? It's pretty straightforward, right? So imagine if we have another number included here, if we put another number like 100%, then we're gonna have a stem of another number, right? We have another stem, and then what's the leaf? Leaf will be 0, right? So 100, the leaf will be the last digit on the right, 0, and everything to the left will be stem 10, right? So this is your stem plot. So we can make a stem plot very easily. What kind of information can we obtain from the stem plot? Okay. So first thing we can look at is mode. If you guys learned some statistic courses in high school, you probably have learned about the mode is. Mode is most frequent, right? So of all the stems, which stem is most frequent? So what values appear the most for all the exam scores, right? So you can see stem 7, stem 8, they have the same amount of stems, right? Same amount of leaves. They are most frequent right here, right? So that's basically where our mode is, right? Mode is between 70 and 80, or if you want to just close by, it's going to be close to 80, right? Between 70 and 80s. That's your mode. And next thing we can look at is center. So what's the center of the data? So center is another. We can find one center without calculating. It's kind of median. So basically, you need to find a mark. From 20s to 100s, you need to find a mark to separate the data into half and half, 50% on each side of that mark. So roughly, the center is about right here as well, right? You have 5 students on top, including this 100, they have 6 students at the bottom. When you look at a stem plot, you don't have to count. Even though for this small data set, you can count, but most of the time, just roughly estimate. Just roughly find a point that separate the whole data into halves, right? So the center is about 80 as well. That's very good, useful information, right? So that the center of the score is about 80. And the next thing we can look at is called the spread. So without calculating, we can get a spread of data by just using like a range thing. So if you look at data, so I don't want to confuse people, let's take this number out. We don't want to include this 100% here. It doesn't really matter much, but okay. So spread, we're going to look at the stem plot. So what is the data ranges in? What are the exam score ranges in, for a small class like this? It's easy to see. It's from 21 to 92, right? So that's spread. That's a very good useful information, right? So this class has score between 56 and 98, and that class has 78 to 100. You know, it kind of gives some, you know, features to compare. And next thing we can look at is shape. So this is might be something that people have not learned if you never take a statistics class systematically. What's the shape of a data? So the shape has three options. Either symmetric or skewed. And for the skew, we have two kinds of skew, left skew and right skew. Right? So symmetric, left skew and right skew. These are the three options for the shape of data. And how do I determine which one is it? Okay, so here's the deal. So I'm gonna try to draw this. Hopefully I can draw it well. So I need to draw a tail from the mode to each side of the tail. So this is where your mode is, right? You draw a tail. If the two sides, the tail on each side are about the same or similar, we call that a symmetric. So you have the same length of the tail. That will be an example of symmetric shape. If one side is longer than the other side, then that will be called a skewed. Then which skew is it? Is it left skewed or right skewed? So we're going to look at the data. The longer tail side is always the skewed side. And if the longer tail side on the small number side, that's called a left skew. Left means smaller number when you have a line axis, right? And the right skew is when the longer tail is on the bigger number side. So then when you look at this, is it symmetric or skewed? Of course, it's skewed, right? Then is it left skew or right skew? It's left skew, right? Because the longer tail is on the small number side. You have 21 here on the small number side, right? So shape. And the last thing we can look at is called outliers, right? So data set has outliers. What are outliers? Outliers are extreme data points. So data points are very, very different from majority of the data set. That's called outlier. So when you look at the data set here, all the scores here, then the majority of the scores here are close to each other, right? But this number is way out there, right? So this number is so different from the majority of the data. So that number is considered as outliers, right? So the student with the score 21 is outlier. So if you want to specify, outlier will be an individual, right? Student with exam score 21. So it's better than 21, but if you write 21, I know what you mean, right? So that's the main features you can get from stem plot. So we learn how to draw a stem plot as well as how to interpret the stem plot, right? The 5 main features: mode, center, spread, shape, and outliers. Okay. So now let's look at the last graph we're gonna make. It's called a histogram. So how do I make a histogram? So in order to make a histogram, first we need to make a frequency table as well, right? So just like this. To make the frequency table, we need to define classes. Sometimes we call it bins. Bins like a range of the numerical values. So for example, we can divide, set the bins as classes from 20 to 30, but including 20, not including 30. And then 30 to 40, including 30, not including 40. So the bin class requirement is they need to be mutually inclusive. You can't have one number fall into both of the classes, right? And also the bin size, the class size need to be the same. So they need to be the same width. So it's 10 on one, need to be 10 on every bin, right? So and so on. So we can build the class from 20 to 30, left inclusive, 30 to 40, 40 to 50, and so on. You can ignore the midpoint here. That's not useful. Sometimes they label it as that. And then frequency. Frequency, basically, you go back count again, right? So between 20 and 30, you look at your data, between 20 and 30, that's one student only, right? So the frequency is 1. And between 30 and 40, there's no student between 30 and 40, so that would be 0, and so on. And 40 to 50 is 0, 50 to 60 is 0, and 60 to 70, 60 to 70, we have one student. And the 70 to 80, we have 3, and 80 to 90, we have another 3, and then 90 to 100, we have 2, right? So then that's your frequency table. And if you want to make a percentage histogram, you can make another column called percent. Just convert each frequency into percentage. You have a total of 10 students, right? So once you have this frequency table, you can make a histogram. So I'm gonna show very quick how to make a histogram here. Hopefully I can draw it. All right. So then we need to draw axes. Let's make it smaller. This is too wide, right? So this is your X and Y's, right? Then the X-axis will be the verb we are describing. So the exam score, that's the variable. And this is a horizontal histogram. If you want to draw vertical histogram, just reverse the axis. Right, so y-axis, depending on if you do a frequency histogram or percentage histogram, you're going to choose either one, right? Frequency or percentage. And then once the axis is put there, then now we need to make sure we label the axes, right? So those axes are numerical. They need to be labeled. So for example, we have 20 here. And then for the same distance, 30. And same distance, 40. And the same distance, 50. 60. 70. 80. 90. It need to be a little longer. 100. And then on y-axis, just label, if you start from 0 here, then you will be 1, 2. Oh, I need to put a 2 there. It's a lot easier to draw it by hand. Okay. So then once the axes are prepared, we're ready to draw, right? So then we basically just like a draw a bar chart. We draw one bar for each corresponding class. So for the first class between 20 and 30, we're going to draw a bar with corresponding height as the corresponding frequency, right? So bar height is 1. And then for 30 and 40, we're going to draw a bar with height of 0. So with height of 0, basically you're replicating the x-axis, right? So you're going to draw a bar with height of 0 right here. And 40 and 50, same thing. 50 and 60, same thing, right? So you draw a bar, but it's not visible. It's basically on the baseline. And then for the 60 and 70, you draw a bar with height of 1. And then 70 to 80, you draw a bar with height of 3. And then 80 to 90, same thing. You draw a bar with height of 3 as well. They're a little off. But, you know, you got the idea. And the last bar is from 90 to 100 with bar height of 2, right? So that will give you, you know, example of drawing a histogram. So you can label the bar height, for example, 1 student here, 1 student here, 3 student here, and 3 student here, and you have 2 student here. So this is your histogram. Then the question is, what kind of information can you get from drawing, you know, the histogram? They actually give exactly the same information as the stamp plot. So for example, we can get mode of the data. So mode is the most frequent class, most frequent score, right? So what class of score is most likely to occur, right? So then they can see both 70 and 80 and 80 and 90 has the same frequencies, right? Then the mode will be somewhere in the middle of them, right? So the mode is about 80 as well, if you can tell. Mode. And then we can also get center of the data. So what is the center of the data? So you need to find a score somewhere to separate the data into 50 and 50, you know, right? Half and half. So basically, you move your cursor on x-axis, move it somewhere to separate 50 and 50%, you know, on each side. And it's obvious that, you know, it will be right here, right? So this mark separate the students half and half on each side. So this will be the center. Center is about 80 as well, right? And the next thing we look at is spread. So just look at the data. Just look at the histogram. Do not look at the data set. We only look at the chart, right? So now what is the spread? What is the score range? We can see the smallest is 20, the largest is 100, right? So between 20 and 100, right? We can tell that. And the next thing we can look at is shape. So the shape is the same idea as, you know, what we did in earlier in stamp plot. You have a mode here. So if you draw a tail on both sides of the center, the mode, I'm sorry, not the center. So if from the mode, you draw 2 tails on each side, right? If the 2 tails are same length, that's symmetric. If one tail is longer than the other, that's skewed. And the skewed side is a longer tail side. If it is a small number, it's left skewed. If it is a big number, right skewed, right? So this will be a left skewed, right? And the next thing we can look at is outliers. So are there any extreme data points, right? So we know there is one student, right? Here that's so different from the majority of the rest of the students. So we have an outlier is students with the exam score between 20 and 30. So that will be an outlier. Okay. So, you can use software to make the histograms very quickly, but it's the same deal. You can, once the histogram is made, you can roughly get the mode, center, shape, spread, and outlier, the main features. And you can make a percent histogram just like how you make a frequency histogram, except that the y-axis is the percentage instead of the frequency. But you can see they look exactly the same, right? Okay. So that's basically the summary of the first chapter. We talked about the data set contains individuals, and individuals could be animals, people, things, any kind of objects. And the variable will be characteristic of the individuals. And when we describe data, we're just describing variables. Most of the time, we describe a single variable, just look at one variable by itself, exclude every other variables, just look at one variable at a time. Occasionally, we look at the relationship between variables. That's what we're gonna talk about after, the first two chapters. Then we talk about describing relationships. Then when you describe a single variable, depending on what kind of variables you're looking at, you're gonna use different graph techniques. So if the variable is a categorical variable, it doesn't matter if it's nominal or ordinal, we're gonna use a pie chart or bar chart. If the variable is a numerical variable, discrete or continuous, you're gonna use either a stamp plot or a histogram. Right? So then pie chart and bar chart, it's very easy to make and easy to interpret. Basically just give you different kind of categories, and a stamp plot and histogram give you some, main features. We can look at mode, center, shape, spread, shape, and outliers. Right? So we need to know how to make each of the chart and how to interpret the results once the chart is provided. And the center and shape and spread, that give you the overall pattern of any quantitative variable. They're very, very useful. And we're going to focus on center and spread for this course. Center and spread, they are the most common measure we measure all the time. Outliers are very, very important. They are extreme points that lies outside of an overall data set. So always look for outliers, because outlier could indicate there's data error and they could bias your study. So let's look at some examples very quickly before it ends. So births are not evenly distributed across the days of the week. And here's average number of babies born on each day of the week in the United States in the recent year. Present the data in the well-labeled bar chart. Would be also correct to make a pie chart and suggest some possible reasons why there are fewer births on weekends, right? So we can, this is a summarized data already. This is like a frequency table for us already, right? Just like the frequency table we have here. So we can make a bar chart and pie chart just directly from the frequency table. We're gonna put the day on x-axis from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And then y-axis will be the birth counts, how many babies are born. So, you can make the bar chart. And is it okay to use a pie chart? Of course, right? So basically, if you calculate the percentage, you can see the total percent will add up to 100%. So it's okay to make a pie chart, right? So you can make a frequency bar chart, a percentage bar chart. They look exactly the same, except the label is different. But by comparing pie chart and bar chart, when you want to compare differences in different group categories, which one is more obvious? Which one is, easier to compare? Of course, it's bar chart, right? It's easy to see, hey, this bar is higher than that, so it has higher number of babies on that day. And the pie, sometimes, when you compare the slice size, you need to compare the angle, right? The label will help, but still people want to visualize it. So bar chart had some advantage over the pie chart because it's easy to compare. So most of the time, pie chart and bar chart are interchangeable, and it's preferred to have bar chart for easy comparison, it's kind of common rule. But if you are describing a lot of categorical variables from the data set, you need to make a lot of bar chart. It will be kind of tedious, right? When people are just seeing a bar chart all the time. So in that case, you can alternate between bar chart and pie chart. So, people can, don't have to get tired of looking at one single chart all the time. So that's the idea. And from either bar chart and pie chart, it's clear that Sunday and Saturday has a lot fewer babies being born than from Monday to Friday. From Monday to Friday, even though there are minor differences, but they are still very comparable. But for Saturday and Sunday, they're clearly lower. So if this is a data set you collected and you describe out and you find this pattern, you need to make sure that pattern is reasonable. If you see any extreme pattern or strange patterns, that might be a good indicator that your data is faulty. So, there might be some mistake. Then in this case, is this a faulty data? Can we suggest a good reason to validate the data? So here's some hint. These babies are born, all the babies are being born. So how can baby be born? Babies can be born naturally or scheduled, right? So for natural born babies, they can born anytime, any day. It should be all the days being the same. But for scheduled, who's going to schedule their birthday? The doctor, right? So a doctor is not gonna want to work on weekends. They want to schedule on weekdays. That's why weekdays has more baby born than weekends. So that explains your data trend. So then that means your data is good to go. Otherwise, if you see something you couldn't explain, that means you're in trouble. So you need to go back to see, hey, does data make sense before doing any further analysis, right? So describing data is very, very useful to give us the main features and trend of the data. All right, so this is a second animal for the attendance points. This is squirrel, right? Another example, how long must you travel each day to get to work or school? And table below give you the average travel time to work for workers in each state who are at least 16 years old and don't work at home. And make a histogram of the travel time using classes of widths of 2 minutes starting at 14 minutes. So basically you start with 14 and then the first class will be from 14 plus 2 will be 16. 14 to 16, including 14, not including 16 will be first class. And then 16 to 18, 18 to 20, and so on. But it's always left inclusive, right? All the classes need to be mutually inclusive. So then once you define your class, from 14 to 16, 16 to 18, and so on, then you can count how many of the states are in each of the class, right? So you have 2, 4, 3, 18, and so on. And then you can make a histogram. Right? So comment on the main features of the histogram. What is the mode? Most roughly, this is, this is obvious. This is mode, right? This is the most frequent. So 23 minutes is your mode. And what is the shape? From the mode, you draw two tails, right? One on each side. So roughly symmetric because two tails are about the same length. And then center, if it's symmetric, the mode is center, right? It's the middle point. And then spread, we can see from, it should be from 14 to 32 instead of 15 to 31. So but between 14 and 32, right? But I'm not going to pick on that. Your answer either way will be fine. Because these are indicating the middle point, not the end point. And the outlier, does it seem to have outliers? Doesn't look like it, right? And of course, we can make a stem plot. This is what the stem plot look like. So between histogram and the stem plot, they both have advantages and disadvantages. Histogram is a lot more widely used because it's easy to look, right? And the stem plot just a bunch of numbers. It's hard, right? But the nice feature about the stem plot is it's easy to make when you have a small data set. For example, you have 20 numbers. All you need to do is separate each number into stem and leaf, and then just put all the numbers on both sides of the line, right? So that's very easy to make. And also, it contains all the raw data. So, the smallest, there's 15.5, and the largest is 30.9. But in the histogram, you don't have those accurate information anymore, right? But when you have a large data set, histogram is definitely the one to go because making stem plot is going to be a headache when you have too many numbers. And another thing is, students sometimes got confused between a bar chart and a histogram. So what's the difference between bar chart and histogram? How can I tell which one is which? Some people look at the gaps in between, but that's not a very good way to look at it because some softwares like Excel used to do, maybe still does, when some software make histograms, they leave out the space in the middle where there's not supposed to. So then how do I distinguish between them? Remember, bar chart is to describe a categorical variable, and histogram is to describe a numerical variable, right? So look at the x-axis. Is this a categorical axis or numerical axis? This is days of the week, right? This is a categorical variable, so this is a bar chart. And then for this, what is this axis? This is a travel time, right? So that's a numerical variable. So this is a histogram, right? So look at a variable type instead of looking at the gaps to identify if a chart is a bar chart or histogram. All right, here's another example about stem plot. So some people, sometimes they want to compare between groups. So for example, we have girls and boys, we have two groups, and their vitamin D levels are listed. We have 20 girls and 20 boys on each side. Then we want to make a stem plot. And when you want to compare the groups, you want to make a so-called a back-to-back stem plot. So what it is you're going to make a common stem in the middle. And then on each side, you're going to make a stem plot for each of the two groups, right? So for example, to make a common stem, you can see for the female, for the girls, the stem range from 1 to 5. For the boys, stem ranges from 0 to 3, right? So the common stem will be, put them all together, 0 to 5, right? So then for the boys on the right, for the girls to the left, you can have a back-to-back stem plot. It can kind of compare, hey, the center look like the girl is higher than the boys, right? On the bottom is higher because it's a bigger value. So don't get confused on the stem plot. Look at the labels of numbers. But is it a good separation between them? It doesn't look at, the center is kind of they're overlapping. It's not a good separation, right? So sometimes if you want to get more details, you can split the stem plot so that, you can get more details. For example, for each of the stem on top, you're going to split it into 2 for each stem. So you have 2 zeros instead of just 1 0, right? For stem 1 is split into 2 1s, right? So for each stem, you can have an upper and a lower stem, right? So the upper stem has a small number. Lower stem will have a bigger number because going down lower, you're going to have a bigger increasing on the value. So then you used to assign all the leaves from 0 to 9 on one stem. Now we just need to redistribute the leaf. So you have upper stem and lower stem. Lower stem will have a larger value of the leaves. Upper stem will have a lower number of the leaves. Lower number from 0 to 4, upper number from 5 to 9, right? So just redistribute the leaf, upper stem 0, 8. So we'll be on the lower stem, right? Upper stem has nothing. And the upper stem 1, you have 2. Lower stem 1, you have 8, and so on. And it goes through for the whole data set. So now you can see it's well separated, much better, right? It's called a split stem plot. Right, so there are a couple of more examples. Basically, just look at different kind of chart and answer the questions. And this is describing data using graphs. And please let me know if there are any questions. Thank you.